Okay, guys, welcome. Today we're going to talk about linear inequalities in two variables. Okay, now think about for a second when you draw a line on a graph. All right, when you do that, you're essentially dividing the graph into two regions. All right, and of course, each of these we're going to refer to as what's called a half plane. All right, now when you replace the equal sign with any of your inequality symbols, instead of a linear equation in two variables, of course, now you have a linear inequality in two variables. Okay. Now, when you have a linear inequality, you're going to get a solution that's basically going to be one of the half planes, right? Because you want something to be greater or less than or something like that. So it's going to be everything that's above or below a line that you have, and it may or may not include that line as well. Okay, so the way that we can go about doing this is the first thing that you're going to do is essentially graph the line as if it were just an equal sign there. Okay, so you graph it as normal, and then if you have the equal sign, you're going to use a solid line. If you don't have the equal sign in your inequality, you would use a dashed line. Okay. Now, the next thing that you're going to do is you're going to choose any point that is not on your line, and you're going to use that as a test point. All right. And most of the time, if you can get away with it, the origin is the easiest one to use. Okay. And then what you're going to do is you're going to substitute your test point into your inequality. Now, if you get a true statement, you're going to shade the region that contains that point. If you get a false statement, then you're going to shade the other region. Okay, so let's go ahead and we'll do an example of this. Okay, so first we want to look at the graph of x plus y greater than or equal to 1. Now, of course, we want to treat this as if it were just an equal sign, and if we did that, we would want y to be by itself. So I want to subtract x from both sides, and I would get y is equal to negative x plus 1. All right, and we're going to graph that as if it were just an equal sign. And of course, since I have the equal sign here, it's going to be a solid line. Right, now if I graph this, we talked about in the previous video that I can plot my y-intercept first, which is positive 1. And then from there, my slope is negative 1, so I can go down 1 to the right 1, and there's my next point. And of course, since it's a solid line, I just make the line as I usually would. Okay, now we see that the origin, of course, is right here, and that's not on my line, so we're going to test 0, 0. If I plug that into my inequality, I'm going to get that 0 is greater than or equal to 0 plus 1. So I get 0 is greater than or equal to 1. Now, since this is not true, we're going to not shade the part containing 0, 0. Right? So since 0, 0 is right here and it made it false, I need to shade this side. Right? So that's what this inequality looks like. Okay. In part B, we have 4x plus 3y less than or equal to 12. All right. So again, I want to get y by itself. So we'll subtract 4x. And I get 3y is less than or equal to negative 4x plus 12. And if I divide by 3, I'm going to get that y is less than or equal to negative 4 over 3x plus 4. So if I graph this, right? So 1, 2, 3, 4. My y-intercept, of course, will be here. And if I go down by 4 and to the right by 3, I get my next point. And again, I have the equal sign, so this is a solid line. So I'm going to get something like this. Okay. Now, again, we'll test 0, 0 since that's not on the line. If we plug that in, we're going to get 0 is less than or equal to 0 plus 4. So 0 is less than or equal to 4. This is true. So we're going to shade the part with 0, 0. So we want to shade this line. All right, so that's the solution. Okay, let's do a couple more. So here, part A, we have 2x minus 3y is greater than 6. So if I get y by itself, I'm going to have a negative 3y greater than negative 2x plus 6. And now when I divide by negative 3, I have to be careful because since we're dealing with an inequality, I have to flip this sign. So I'm going to have this now, less than. So I get a positive 2 over 3x minus 2. So if we graph this, I have a y-intercept of negative 2, so that's here. And then I would go up 2 and over 3 to get my next point. And since there isn't an equal sign here, I'm going to have a dashed line, so something like this. Okay, now if we test 0, 0 again, I'm going to get that 0 is less than 2 over 3 times 0, which is just 0, minus 2. So I get 0 is less than negative 2. And this is not true. So I need to shade the side that doesn't contain 0, 0. So I need to shade this. Okay. In part B, we already are given slope-intercept form, so that's nice. So if we plot this, I have a y-intercept of 1, so I'm going to put a point here, and then I'm going to go up 2 and over 1. We have a solid line since we include the equals, so there's the first part. Okay, if we test 0, 0, we're going to have that 0 is less than or equal to 1. And this is true. So since 0, 0 is here, I want to shade this part. Okay. Part C, we have y plus 3x is greater than negative 2. So if we get y by itself here, I just need to subtract 3x. And I get y is greater than negative 3x minus 2. So if we graph this line, I have a y-intercept of negative 2, so that's coming here. And then my slope is negative 3, so I need to go down by 3 and to the right by 1. So again, there's no equal sign, so we're going to use the dashed line here. I'm going to test 0, 0, which of course is right here. So I'm going to get 0 is greater than 0 minus 2. Of course, this is true. So I want to shade the side containing 0, 0, so I'm shading this side. Okay. Last example on this slide. We have for part D, we have y is greater than or equal to negative x plus 1. Okay, so we have another one that's already given to us in slope-intercept form. So if we graph this line, we have a y-intercept of a positive 1, and we need to go down 1 and to the right by 1. Since we have the equal sign, we'll have a solid line again. And of course, 0, 0 is fine because that's here. So we'll test that. We'll get 0 is greater than or equal to 1, which is not true. So we're going to shade the opposite side. Okay, so that's that example. Okay, now a couple more. In part A, we're going to see why, we're going to see an example of when we couldn't use 0, 0, right? So y less than x is already in slope-intercept form. If we just graph the line y equals x, of course, it's a dashed line, so we're going to have something like this. Now, we can't use 0, 0 because 0, 0 is on the line. So we need to use another point. So we could use, for example, 1, 0. So here we'll test 1, 0. So if we plug that in, we get 0 is less than 1, which is true. So we're going to shade the side containing 1, 0. Okay, so that's part A. Now in part B, we just have 2x is less than or equal to 5. Well, if this were an equal sign, we would solve for x and we would get x is greater than or equal to 5 over 2. But this is just a vertical line. So where's 5 over 2? 5 over 2 is a little bit bigger than 2. So we have a vertical line, here. And if x is greater than 5 over 2, I want this side of that line. Okay, similarly in part C, we have a 2y greater than or equal to 7. And this would be a horizontal line. We get y greater than or equal to 7 over 2. So now 7 over 2 is halfway between 3 and 4. So we're going to get this. And of course, a solid line because we include our equal sign. And if y is greater than 7 over 2, I need to shade up here. Okay. Part D, we have x is less than -2. So again, this is another vertical line. And here we have a dashed vertical line. Now, if we're less than -2, I want to shade this part. Okay, one last example before we wrap this up. We have y is between 1 and 3 with 1 included but 3 not. Okay, now if these were two separate inequalities, we would have from the first one, y is greater than or equal to 1. I just reordered that. And then this one would give me y is less than 3. And we want to solve both of these at the same time. Well, y equals 1 would be here. And y equals 3 would be here. Now, I want to be greater than or equal to 1, so I want to be above the red line, but I'm less than 3, so I need to be below the purple line. So it looks like we're going to want all the stuff that's in between here. All right, so that's our solution for this one. So that concludes this video on linear inequalities. I hope you enjoyed, and I will see you next time.